Welcome to Educator.com. Today's lesson focuses on solving systems of equations using addition and subtraction. The fundamental principle underlying this method is that adding or subtracting two equations also yields an equation. We're going to use this principle to solve systems of equations. For example, I may have a system of equations 2x plus 5y equals 10. Second equation in the system is 6x minus 5y equals 6. I'm allowed to add these together, and I will see that I get 8x. This variable drops out, equals 16. I can then solve for x, and I get x equals 2. Once I've got x equals 2, I can go ahead and substitute that back in to one of my original equations to solve for y. What makes this work is when I added, one of the variables dropped out. What I ended up with is one equation with one unknown, with one variable, which I could then solve for. This is the ideal situation where the equations are already in such a form that when I add, one of the variables drops out. Even if they're not already set up that way, you can certainly use this method. You just have to take some extra steps to get the equations in a similar form. But the underlying principle is that by adding or subtracting two equations, you can get a variable to drop out, leaving you with one equation with one unknown. And we'll see this in the example. This example asks me to solve the system 3x minus 2y equals 12, 4x plus 2y equals 16. Now, this is an excellent approach to use, addition or subtraction, when I see that the two variables have this, that both x's or both y's have either the same coefficient or opposite coefficients. So addition or subtraction technique works well with variables with the same or opposite coefficients. For example, if I have one equation that has a 3y and the other equation has negative 3y, I can add those together and they'll drop out. Or maybe I have 2x in one equation and 2x in the second equation. If I subtract the equations, the x's will drop out. So remember, for substitution, I said the ideal situation is when you already have a variable with a coefficient of 1. If you have one variable with a coefficient of 1, you're in good shape to do substitution. For addition or subtraction technique, what you're looking for are variables, either both y's having the same or opposite coefficients, or both x's having the same or opposite coefficients, so that you can get a variable to drop out when you add or subtract. So looking at this setup, I have minus 2y and plus 2y. Makes it very easy to apply addition to solve this system of equations. Okay, so when I add these two equations, what I'm going to find is that I end up with 7x. My y drops out. And then I have 7x equals 28. Solving by my usual method, I'm going to isolate the variable by dividing both sides of the equation by 7. And I get x equals 7. Excuse me, x equals 4. X equals 4. Divide both sides by 7 to get x equals 4. Now, once I have x equals 4, I can substitute that back in to one of these equations. And I'm going to go ahead and select the top equation, the first equation. 3x minus 2y equals 12. Substitute 4. That's going to give me negative 2y equals 0 when I subtract 12 from both sides. Dividing both sides by negative 2, I get y equals 0. My solution to this system of equations is then that x equals 4 and y equals 0. Recall that you can always check your answers by putting these values back into one or both equations. So 3x minus 2y equals 12. I could go ahead and put in 3 times 4 minus 2 times 0 equals 12. And what I'll get is 12 minus 0 equals 12. And 12 does in fact equal 12. So this equation held up, and that verifies my solution that x equals 4 and y equals 0. So that was solving by addition. In this next example, I have a system of equations. 3x minus 6y equals 12. 3x minus 4y equals negative 8. I see that I have the same coefficient for the x's. So in both the first and the second equation, I have 3x. This time, I'm going to need to subtract. Last time I added, because in the last example, the variables had opposite coefficients. So if I had 3x and negative 3x, I would add. But here I need to subtract. Okay, the thing about subtraction is being really careful with the signs, because if you don't reverse the signs, then you end up with the wrong answer. So what I'm saying is that I'm going to subtract the second equation from the first. So I have to reverse each of these signs. So it's 3x minus 3x. That's going to give me 0. For my second one, I have negative 6y minus negative 4y. Remember that in reality, this is saying plus 4y. Okay, so that is going to give me negative 2y. Then I'm going to have 12 minus negative 8. And then minus negative 8 is actually a positive. So what I'll end up with is 20. So when I go ahead and solve this out, I get minus 2y equals 20, which is going to give me y equals negative 10. Once I have that, the rest of it is pretty simple. I just need to substitute y equals negative 10 into the first or second equation, into either equation actually. I'm going to go ahead and substitute it into this first equation. 3x minus 6y equals 12. That's 3x minus 6 times negative 10 equals 12. Or 3x plus 60 equals 12. Okay, once I get to here, it's a simple matter of just isolating the x. 60, subtract from both sides to move that over to the right side of the equation. So I get 3x equals 12 minus 60, which is negative 48. Divide both sides by 3, and I get that x equals negative 16. So my solution is that x equals negative 16 and y equals negative 10. Just going back to this point of subtraction for a minute, because like I said, a problem is that people sometimes forget to reverse the signs and they miss it. So another way to handle this, instead of just leaving it as subtraction, is to convert to addition. So if instead of saying 3x minus 6y equals 12 minus 3x minus 4y equals negative 8, what I'm going to do is instead add the opposites, or multiply by negative 1. So this is the same as saying adding negative 3x, negative times negative is positive, adding 4y, and then adding 8. So instead of saying minus 3x minus 4y equals negative 8, I'm going to say plus negative 3x plus 4y equals negative 8. Same thing, only I've actually written down the signs reversed instead of just doing it in my head, because I risk an error when I just do it in my head. So you may want to take this extra step. Okay, solve the system. Minus 6x minus 4y equals 50. 4x minus 4y equals negative 10. What I have here is negative 4y and a negative 4y. Now, if I just add those, I'm going to get negative 8y. That does not help me. What I need to do is subtract them. Because when I subtract them, this sign will reverse. I'll get negative 4y plus 4y, which will be 0. So when I have the same coefficient like this, I need to subtract. So I'm going to solve this system of equations by using subtraction. Minus 4x minus 4y equals negative 10. And I'm going to go ahead and switch all my signs because I want to make sure I don't make a mistake. So this would be the same as negative 6x minus 4y equals 50. I'm going to go ahead and reverse my first sign. So I'm going to now add negative 4x. My second sign, I have a negative and a negative, so I'm really multiplying by negative 1. And that's going to give me a positive 4y. Here I have a negative and a negative, so that's positive 10. Now I don't have to worry about the signs. I just simply add. Okay. What I end up with is negative 10x, my y's drop out just like I wanted, equals 60. Therefore, x equals negative 6. Now we're at the point where we just go ahead and substitute in for that first equation. Minus 6x minus 4y equals 50. Substitute negative 6 in. So that's negative 6 times negative 6 minus 4y equals 50. Or 36 minus 4y equals 50, which gives me negative 4y equals 14. I'm going to start back up here in the second column. That negative 4y equals 14. Divide both sides by negative 4 to get y equals negative 14 fourths, or y equals negative 7 halves. Okay, so my answers are, my solution is y equals negative 6, x equals negative 6, and y equals negative 7 halves. Okay, so for this, I saw that I had the same coefficient for the y's in both equations, so I knew I needed to subtract. So I set it up here showing subtraction, but I took the extra step of just converting the signs before combining the equations to make sure that I had all my signs correct. So that became a negative 4, positive 4y, and negative 10. Adding these two together, I got negative 10x equals 60, or x equals negative 6. Since x equals negative 6, I can just substitute into the first or second equation. I picked the first equation, substitute in for x, and that gave me this equation. I went ahead and solved for y, finding that y equals negative 7 halves. So x equals negative 6, y equals negative 7 halves. In my fourth example, I have a system 3x minus 2y equals 8, minus 3x plus 2y equals negative 4. This is a very simple situation in terms of using the addition principle because I have opposite coefficients. So when I have opposite coefficients, all I need to do is add the two equations together, and then this second equation is going to, the variable is going to drop out. One variable will drop out. So I'm adding these two. And what I'll see is I had 3x minus 3x. Great, that drops out. I have 0. Well, I also actually had opposite coefficients for the y's. So I had two sets of opposite coefficients here, and you know what's going to happen? The y is going to drop out as well. So now I have 0 and 0 equals 4, or 0 equals 4. But we know that 0 doesn't equal 4. This is that situation that I described in a previous lecture where I have a constant, where I end up with something that says C equals D, that's saying one constant equals another constant. But since that is not true, what I have is no solution. There is no solution for this system of equations. And I looked here, I may have seen right away that I actually had two opposite coefficients. Both variables had opposite coefficients. And when I combine those two equations, when I add them, I'm going to end up with both x and y dropping out, which gives me 0 equals 4, which is not true. Today on educator.com, we discuss solving systems of equations through addition and subtraction. Next time, we'll be doing another method for solving systems of equations.